in order to maintain and improve their health, which can have a subsequent positive impact on growth and efficiency. This is especially true with milk replacer because the pre-ruminating phase is the most vulnerable of a calf's life cycle. However, with growing concerns and regulations regarding antimicrobial resistance, there is a need for an effective alternative to these antibiotics. That's where the Lactobacillus and Bacillus containing probiotic comes in. The positive bacteria, being the Bacillus and Lactobacillus species, are introduced, and they're meant to limit the growth and reproduction of harmful bacteria, thus influencing the GI tract microbial populations and having that positive impact on health. The research gap exists, however, and does it actually work? That's where the objective of our study was to discover the impact of probiotic-containing milk replacer on pre-ruminating calf growth and performance. So this study included 44 pre-ruminating calves, half Angus, half Holstein genetics. Their average weight was 39.3 kilograms. They were blocked by age in groups of 6 in a randomized complete block design. Then they were assigned to 2 treatments, one where they received milk replacer with no probiotic, or one with a milk replacer containing 1.25 times 10 to the 9th coliform forming units per head per day of the Lactobacillus and Bacillus blend, which is complements of Church and Dwight animal nutrition. On day 1, initial weights and hip heights were recorded. Calves were tagged and given colostrum. Intake for the milk replacer, which was given from day 0 to day 30, and grain, which was given from day 15 to day 30, were recorded daily in order to calculate average daily feed intake and average daily gain to feed ratio, which is their efficiency. On day 30, their hip heights and calf weights were again taken. That's in order to calculate overall growth and their average daily gain. So that leads us into our results. On all of these charts, these represent the most significant outcomes of this research study. Now, on the y-axis of all of them, you'll see the response criteria and their given units. However, on this first graph, in the upper left-hand corner, I opted to show average calf weights a little bit differently. On the x-axis, you'll see the days since trial introduction. This is to show the outstanding difference of p equals 0.02 in 0-day weights and why we decided to use them as a covariate. After that, on this graph in the right-hand corner is average daily gain. That was represented in kilograms per day and had a p-value of 0.015. Gain to feed ratio is represented below. That's given in kilograms of gain per kilograms of feed. And then the p-value on that one is 0.0008, so a very significant difference. From there, we can draw several conclusions. Now, inclusion of the probiotic had no significant effect on daily intake, and hip height and overall growth were also not affected. However, calves that were fed the milk replacer containing the probiotic had a greater average daily gain and gain to feed ratio than those that received the control. From that, we can conclude that without impacting overall intake, the probiotic inclusion had a positive impact on calf growth performance. Now, there is additional research that could be conducted, needed to determine the probiotic's mode of action, and then evaluate its impact relative to an antibiotic containing positive control in order to determine if it's an effective alternative. To close out my presentation, I'd just like to say thank you to the Dr. Mark and Kim Young Undergraduate Research Fund and Church and Dwight for their financial support of this product and the overall undergraduate research class. Thank you.